Hey everybody, welcome to another important session and an interesting one in this arena of the math trail where we are looking into recurrence relations. And in the previous videos, we have talked about the overview of recurrence relations, the types of relations, recurrence relations, and then the different types and different ways in which we solve them, right? So in one of the last videos, we discussed about solving recurrence relations using the iteration method. So when you say solving a recurrence relation, what you typically mean is finding out the closed form solution to the sequential expression, right? So in this video, we're going to look at solving recurrence relations using another method called as characteristic equation method, right? So let's jump straight into the whiteboard. So the characteristic equation method is used to solve those recurrence relations which belong to the category of linear homogeneous relations with constant coefficients. All right, we have already looked at what are linear recurrence relations, what are homogeneous recurrence relations, right? So linear homogeneous recurrence relations with constant coefficients, we solve them using characteristic equation method. So let's take an example here. So let's say a n equals 5 a n minus 1 plus 6 a n minus 2, right? Where n is greater than or equal to 2 and a naught equals 1 and a1 equals 3. So these are the base conditions. A naught equals 1 and a1 equals 3, right? So let's go about solving this. So how do you solve this first? What you do is you assume that an equals r raised to n, okay? So the first thing is an equals r raised to n, right? So by this understanding, we understand that n minus 1 equals r raised to n minus 1. And n minus 2 equals r raised to n minus 2. All right, so we substitute these values here. What you get is r raised to n equals 5r raised to n minus 1 plus 6r raised to n minus 2, all right? So now we divide both the sides by r raised to n minus 2. All right, so what do we get? R squared equals 5r plus 6, right? So if you write this down, it becomes r squared minus 5r minus 6 equals 0, right? Okay, so that's the quadratic equation. Now we solve this quadratic equation. This becomes r squared minus 3r sorry, I meant to write this as actually a plus, right? So this is supposed to be minus, all right? So just substitute that. So minus, all right? So this right? So this is a minus. So the original equation, it should be a minus here, not a plus, right? This thing. It should be minus, not a plus. Okay, that's a small change here, right? So now this becomes r squared minus 5r plus 6 equals 0, right? So r squared minus 3r minus 2r plus 6 equals 0, right? So this again implies r into bracket r minus 3 minus 2 into bracket r minus 3 equals 0, This implies r minus 2 into r minus 3 equals 0, which means r equals 2 or 3, right? So these are the roots of this equation, right? So now the next step is, in this characteristic equation method, the next step is, what we do is the general solution is given like this, like an equals a r1 raised to n plus b r2 raised to n, right? Now this is the solution when the roots are real and distinct. So you see 2 and 3 are distinct roots, but in case you have two equal roots, right? 2 and 2, say for example, or 4 and 4, something like that. Then the solution is slightly modified, is given by a r raised to n plus b n r raised to n, all right? That's the only difference here. Maybe I can take that example later, maybe in another video, but then that's the only difference here. But for now, let's look at this solution, right? So we substitute that. So we have a naught equals 1 and a1 equals 3, right? So let's solve this now using the substitution. So a0 equals 1, which basically equals, so for a0, it should be a into 2. So r1 is 2, right? So 2 raised to 0 plus b into r2 is 3. 3 raised to 0. This implies 2 raised to 0 is 1, 3 raised to 0 is 1. So this implies a plus b equals 1. So that's the first equation, right? Second one, so a naught equals, sorry, a1 equals 3, right? That's what we have shown here. a1 equals 3. So a1 equals 3 equals a into 2 raised to 1 plus b into 3 raised to 1, right? This implies that 2a plus 3b equals 3. So let's substitute. So from this, we understand that b equals 1 minus a, right? So let's substitute this in this equation. So we get 2a plus 3 into 1 minus a equals 3. So that implies 2a plus 3 minus 3a equals 3. Right? So minus a, this implies a equals 0, right? And this, and if you substitute this here, you get b equals 1. So what is the final equation here? Substituting the value of a and b here, we get, so a equals 0, right? So this thing becomes 0, b equals 1. So this means that an equals r2 raised to n. What is r2? R2 is basically 3. So an equals 3 raised to n. That's the final closed form solution of this. It's become a bit complicated here, but then maybe I'll try to write it one below the other in the next classes. But then, yeah, this becomes a closed form solution. So the closed form solution of this recurrence relation, right, subject to n greater than or equal to 2, and then these base conditions is nothing else but these base conditions. It's nothing else but an equals 3 raised to n, right? So I hope that's been helpful. If you have any other equations to solve, if you have any questions to solve, just let me know in the comment box and I'll be happy to make a video solving them, right? So I'll see you in another video, and then I wish you all the very best with your preparation and with your studies. So until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.